Welcome to your notes on input and output tables. So we're going to get started. So the first thing that we did today is we played a game called Guess My Rule. So you guys are going to guess what the teacher's rule is based on the output that I give you. So for our input here, what I'm going to give you is I'm actually going to give you the input and outputs since we actually played this in class and students gave me specific ones. So I'm going to say my input where somebody said a 2. So my input is 2, and then 4, 6, and 8. So we're going to use those throughout this video, those 4 input values, 2, 4, 6, 8, for the first 2 examples. So if somebody said, okay, your input is 2, I would say my output is 9. So this is the answer I would give the students. And if they said 4, I'd say 11. And then if they said 6, I would say 13. And 8, I would say 15. So now what I'm going to help you with the first one here. So I know the input is 2 and the output is 9. Now to get to see what the change is here, these are increasing by 2s, right? So each time these students said, I want to do even numbers, so 2. So I would have 2 something will give me 9. Well, how can I get from 2 to 9? Well, I know that 9 minus 2 would be 7, so let's check. Is my rule add 7? Well, let's see. If I add 4 plus 7, if I add 4 plus 7, will that give me 11? Well, let's see. 4 plus 7, 7, 8, 9, 10, 11. So it does give it to me. But let's double check the other ones. So if I add 6 to 7, that isn't going to indeed give me 13, and 8 plus 7 would give me 15. You can also look at it here, 9, 10, 11, 11, 12, 13. So it's increasing by 2 here and here, but we wanted to figure out what the rule was. So essentially what our y-intercept would be. So I'm going to actually have you, I'm going to give you the inputs, so 2, 4, 6, 8, and I will give you the outputs here. And I want you, after I'm done plotting out what the outputs are, I want you to try to figure out what would be the rule. So for here, it was add 7. What did I do here? So take a moment and pause the video and see if you can figure out what the rule is. Alright, now that you've paused the video and figured out the rule, from 2 to 6, well, I know that I could add 4, but 4 plus 4 isn't 12. Neither is 6 plus 4 is 18. So I know that it needs to be maybe a much larger number. I know that it's probably not adding, but multiplying. So I know, based on my information of how I can't add or subtract, it's either going to be multiply or divide. Well, I know that it has to be multiply and not divide because 2 divided by something, so it could only be 2 and 1. So I know I have to multiply 2 by some number to get 6. Well, I have to multiply by 3. So let's test that theory. We're going to do 2 times 3. Does that give me 6? Absolutely. 4 times 3. Yep, that gives me 12. That checks out. And I want to make sure that all of these work out in order to guarantee that all of my input values had the same number multiplied to get my output. So let's look at the bottom three, or the bottom two here. Okay, so for these two bottom ones, I'm going to give you the inputs 1, 2, 3, and 4 for this one. So my output for 1 is going to be the number -3. For 2, it's going to be -1, 1, and 3. So now I want you to pause the video again, and I want you to figure out if you can find the pattern of these input and outputs. All right, so let's see. You can find the slope of it, you know. So from -3 to 1 is going to be doing what? Well, adding 2, right? And let's verify. -1, 0, 1 would be adding 2, and 1 to 3 would be adding 2, right? Okay, so I know, and this is another strategy that we can use, I know my slope is a 2. But now here's the cool thing. If I wanted to figure out, because my y-intercept, right? My y-intercept tells me where I start on the y-axis. So when x is 0, I need to figure out what the output is when x is 0. Well, instead of adding 2, I can actually subtract 2 from -3. So -3 and a -2 is going to give me a -5. So in this instance, my rule that I need to do, because if I create an equation, it would be 2x minus 5. What I need to do to my x's is, or my inputs, I need to double by 2 and subtract 5 from that total. So let's test it out. If I put a 1 here, so if I double 1, so 2 times 1 would give me 2, and subtract 5, so minus 5, would indeed give me a -3. How crazy is that? All right, so take a moment, catch up with everything here, and see if you can use this strategy to solve for the next one. So we're going to use the same inputs, 1, 2, 3, and 4. And our outputs are actually going to be 4, 1, 10, and 2. Take a brief moment and look at the differences between these. So now that you've paused your video, what I can notice here is I'm jumping from 4 to 1. Well, that's -3, but then I add 9, and then I subtract 8. That's not really making any sense to me, right? So what I can actually do is I can look at just the even numbers. I could look at just the odd numbers and see what's happening. So let's look at the even numbers first. So even numbers, I have 1, 4, and 3, 10. If I just created a table from 1, 1, 3, 5, and so on and so forth of odd numbers, I could see a pattern. Well, how can I get from 4 to 10? By adding 6, right? So if I keep adding 6, and obviously because we have our inputs, the change would be +2. So my slope, remember, is rise over run, so 6 over 2. So I know this is changing by 3 each time. Okay, so if I actually went backwards from here to figure out what 0 would be, what could I get? Well, I know that every other one is adding 6, so maybe I should look at the even ones. So let's actually look at the even ones now. So I have 2 and 1, and 4 and 2. Well, how in the world can I get from 2 to 1 and 4 to 2? Well, I know that I can add here, plus 2. So, and I can add 1 here. So rise over run. Okay, so I'm taking half of the number. So it looks like for the even numbers, I take half of it. So all I'm doing for the even numbers is dividing by 2. So even numbers divide by 2, or cut in half, essentially, because if I cut something in half, it'll give me half of that. Now for the odd ones, we're going to go back to, since I can't really tell what it's going to be, well, let's actually look at what we have so far. So we know that we need to, our slope is multiplied by 3, so I need to multiply my input odd numbers by 3. So odd numbers, we're going to multiply by 3. And then if I multiply my 1 times 3, that'll still give me 3. But how the heck am I going to get to 4? Well, 3 to 4 is plus 1. So after I multiply, I'm going to add a 1 to each of them, which will work here because 3 times 3 is 9, plus 1 does in fact give me 10. Now this one was a little bit more difficult to understand, and that's totally fine. This one actually had 2 different rules for this, so don't beat yourself up too much. But let's look at the examples for the next one. So instead of asking for inputs, we're actually going to be creating our own inputs and putting our own outputs out. So you're going to fill out an input and output table based on the rule given. So they give you the first input, which is going to be 3 over 4, and their output is 7. So what the rule is, it tells you right here, add 1, then multiply by 4. So I'm going to choose, let's do 2 and 8 and 10. Why not? You can honestly choose whatever numbers you want. So what this says is I'm going to add 1. So that's going to give me 3. Then multiply by 4. So I did the first step, and now I'm going to multiply by 4. 3 times 4 is 12. And I'm just going to continue on with this pattern until I get all of these numbers right here. So 9 times 4 is going to give me 36. And 10 plus 1 is 11. Times 4 gives me 44. So now what you're going to do for the rest of these is you are going to choose your own input and make sure that you follow what the output is telling you. So it says name the digit in the tens place. So for these ones, 3 over 4 is actually 0.75, and the tens place is the first one after the decimal. So I would choose fractions such as like 1/4, 1/3, 2/6, anything like that to figure out what the number will be in the tens place.